Good afternoon. Welcome to EduSet Network. Friend, as you know, this week we are going to discuss on different issues of geography, and today we are starting with the lecture Weather and Climate. We will try to understand the weather and climate in perspective, and we'll try to understand the different elements, what is the role in atmosphere of weather and climates. You all are aware about the weather forecasting, so we'll try to understand how the forecast is done and what are the different agencies involved in forecasting the weather. And this is the right time because we are in the mid December, so this is the time everyone see how the climate is going to change, how the weather is going to change. So we'll try to understand weather and climate in today's lecture. And for discussion on this very topic, we have in the studio senior faculty Dr. R.V. Singh. He is the head of the Department of Geography in Delhi School of Economics and has held several important positions. And he is also vice president of International Geographical Union, and he is a member IGU of Indian National Science Academy, and he has delivered a lecture in different forum, national, international forum, and contribute in different journals. So I think his knowledge and experience will help us to understand this topic, weather and climate, and give insight how to understand this weather forecasting. So on behalf, I welcome him for the EduSet lecture. Welcome, sir.
Thank you, Amarendra ji. Dear viewers, today we are going to discuss weather and climate. Then in subsequent lecture also we are going to understand heat budget, pressure belts, then natural disasters, tsunami, and also at the end we'll try to see also the hydrological cycle. So it is very important for us to understand what is weather, what is climate. You know, weather, very broadly speaking, I can say that weather is defined as the state of atmosphere of some place and time, usually expressed in terms of, temperature, air pressure, humidity, wind speed and direction, precipitation, cloudiness, and generally meteorologists, study weather situation. On the other hand, the climatologists study climate. Climate is defined in terms of the average mean of several weather elements, such as particularly I would like to highlight here temperature and precipitation over a specified period of time. And here I would like to mention that 30 years according to as defined by WMO, World Meteorological Organization. The difference between climate and weather is usually summarized by the popular phrase, I quote, climate is what we expect, weather is what we get. Here I would like to elaborate little bit this both attributes and both phenomena, and particularly in the context of the heating the atmosphere. Because the earth axis is tilted, and sun's light is incident at different angles at different latitudes. Higher latitudes have a lower angle of incidence, which results in less heating than at lower latitudes nearer to equator. A secondary cause of temperature difference on the earth is that different surface areas such as ocean water, forest lands, ice sheets have different type of reflectivity and therefore absorb and radiate different amounts of solar energy they receive. So, in nutshell, I can say weather is a state of atmosphere at some place and time, but on the other hand, climate is an average of weather elements, particularly, a specified time, and time as defined by the WMO is 30 years. In this, I will elaborate a little bit and compare this weather and climate. Weather, it is a totally instantaneous atmospheric condition. On the other hand, the climate shows the average atmospheric condition. weather can change rapidly within even less than 1 hour, but on the other hand, climate sustain over a longer time, and particularly the 30 years period, as already I mentioned. Weather prevails over a short area. On the other hand, the climate prevails over a large region. Weather has only limited predictability. On the other hand, climate is almost constant, and largely meteorologists can study the weather, and climatologists they study the climate. Now I would like to take here the different components of the weather: precipitation, humidity, cloud cover, sunshine, air pressure, wind direction, wind speed, and temperature. Then it is very important for us to understand the climate zones around the earth, and you can see the both sides, North Pole and the South, we have the polar region, followed by temperate, the both sides, and then in the middle we have the humid region, and both sides of the humid region we have the arid climatic situation. So this one is a broader, the climatic zones all over the world on the globe. Now I would like to elaborate little bit how we can understand the climate. And as you know, the two most important aspects of climate are temperature and precipitation. And these factors determine what types of species, even the biome, will be found in a particular location. And I would like to remind you the very well-known important theory, altitudinal, propounded by the C. Troll, what it is known as altitudinal vegetational zonation model. Actually, this means the vegetation varies according to altitude. So climate in area is determined by latitude, direction from which winds arrive, proximity to large bodies of water and mountains. So these are the important factors influencing the climatic situation of any region or specified area. Climatic variables, while experiencing the climate as a hot or cold, we realize that climate is the result of a delicate balance between several elements, which includes atmosphere, water system, living organisms, topography, and these elements determine various factors that govern the climate. Of these, the most important factors that are taken into account are rain, atmospheric pressure, wind, humidity, temperature. Now through this diagram you can see the measurement of climatic variables, and particularly showing rainfall through the bar, and then showing this main red color, this mean daily maximum temperature, and then the blue one, the mean total rainfall. For any regions, taking into consideration of this temperature in degree centigrade and rainfall in millimeter or centigrade, such type of the diagram and can be prepared, can be made, and the climate of the region can be depicted. Temperature. It is a physical property of matter that quantitatively express the common notion of the hot or the cold, Then quantitatively, temperature is measured with thermometers. Much of the world uses the Celsius scale for most temperature measurement. Temperature in the atmosphere, by examining this measurement collected by radio, sound and aircraft and later by the rocket, scientists become aware that the atmosphere is not uniform. And so that is why all over the world and the globe, even within the small region, we have the diversity, variation in the climatic situation. And that situation depends upon the various factors already highlighted earlier, maybe the altitude or the topography or the mountain situation or the water system. Many people had long recognized that temperature decreases with altitude. Through this diagram, you can see that how temperature is decreasing in the troposphere, then also increasing in stratosphere, again, mesosphere, and later on, again increasing. So one can see a mixed type of the situation. Through this diagram, I would like to put before you the heat budget of the region. That is a very, very important aspects of the climatic processes. Here you can find the two very clear-cut outgoing long-range radiation and the incoming, solar radiation, and then we have also the reflection of the solar. You can see this, the incoming solar radiation also absorbed by the surface. Even you can see the several type of the surface radiation, evapotranspiration. These are the processes and the several, one can see here the quantitatively this the different type of the balance, heat budget balance between incoming solar radiation and outgoing long range radiation. Precipitation. It is any product of the condensation of atmosphere water vapor that falls under gravity. There are many different types of precipitation like rain, snow, hail or sleet. The standard way of measuring rainfall or snowfall is the standard rain gauge. That is a clear-cut measurement, very well-known measurement. Pressure in the atmosphere, that is a very, very important aspect, and through the diagram also you can see that how with altitude, the pressure also the decreases. So atmospheric pressure can be imagined as the weight of the overlying column of air. Unlike temperature, pressure decreases exponentially with altitude, and it is very much well reflected in this diagram. Terraces of the atmosphere can be detected as far as 500 km above the surface of the earth, but 80% of the atmosphere mass is contained within the 80 km closest of the surface. Atmospheric pressure is generally measured in millibars, and the unit of measurement is equivalent to 1 gram to per centimeter square. Humidity, another very important element of the climate. It is the amount of water vapor in the air. Water vapor is the gas phase of water and is invisible. Humidity indicates the likelihood of precipitation. So, on that basis, I think it is possible also to forecast and predict the precipitation, dew or fog. There are three main measurements of humidity: absolute, relative or specific. Device used to measure humidity is called a cyclometer or hygrometer. Wind, it is a flow of gases on large scale. On earth, wind consists of the bulk of movement of the air. In meteorology, winds are often referred to according to their strength and the direction from which the wind is blowing. Weather indicates the direction of the wind, and wind speed is measured by anemometer. It is very important, dear viewers, it is very important also to see that several factors influencing the climate. And on that basis, it is possible also to understand the climatic processes in the atmosphere. A region's climate is generated by the climate system, which has 5 components: atmosphere, hydrosphere, cryosphere is a more, the snow and glaciated area, land surface, and the biosphere is a more, the biological system within the system. The climate of any particular space or place is influenced by a host of interacting factors. It is not necessary. It maybe the one factor may be dominant, but many other factors interact with each other and influences the climate, like latitude, elevation, nearby water. Within one can see a very clear-cut trend in the climatic situation near the sea or near the river, ocean currents, topography, vegetation, prevailing winds. Now you can see this, through this diagram how you can see this latitude. Surface temperature vary with latitude. Elevation, climatic zones coincide roughly with elevation ranges. If you see the nearby water, sea surface temperature, it is very important measurement affect the land temperature, and so even sometime for the climatic change measurement, SST, the sea surface temperature as an indicator taken into consideration. Ocean currents like water temperature indicate transfer of heat energy by the currents from one place to another place. Then the topography, local variation in elevation can cause the local variation in climate. Vegetation is very important, biospheric aspects of even the hydrological cycle and the climate system, the type of the ground cover and seasonal changes affect the climate. So that is why the forest, afforestation and deforestation, these two are the very important aspects for measuring the climatic processes, and this afforestation and deforestation influences the climate system, CO2 and also the greenhouse gases. Prevailing winds deliver air masses with a specific properties and then influences the climate. Dear viewers, I would like to here through this diagram try to explain the global air circulation, how the emergence of different types of the warm and the cold air. You can see in the upper parts air cools and descend at the lower latitudes, so this process. Then the warm air rises below this belt. We have the warm air rises and moves towards the pole. Then particularly in both atmosphere this may be applicable. So northern hemisphere or the southern hemisphere, almost the same type of phenomena. So the first you can see the upper part, you can see how the cold air and descending in the lower latitudes. Then warm air rises and moves. Then from the equator you can see the air cools and descends at the lower latitudes. So this type of the process, and so that is why you can find the hot desert closer to equator. Also the role of westerly one can see here very visible, and this process even influences the even cyclonic pattern all over the world. This westerly and these winds, the highest solar energy input is at the equator level, and that is a very important factor for influencing the climatic situation. Through this diagram, I would like to particularly looking the air, global air circulation, ocean currents, and the biomes, and you can see that we have at the equator the tropical rainforest. So now you can see here that how the vegetation emerges with the different type of the climatic phenomena. Altitude play also the very important role here, and so that is why the sea trawl, once a geographer propounded the very well known theory, what it is known as the altitudinal vegetation zonation theory. So you can see the tropical rainforest, largely dominant near the equator. Then we have both sides, almost the 30-degree tropical deciduous forest. Then we have the more dry and the desert area, then followed by the both sides, the temperate zone or the grassland, and then the polar area. And you can see the lifestyle and the even the different type of the animals or the species of animals also vary according to the different region and different altitudinal zones. It is very important for us to understand the different type of the climatic classification and what type of the factor we classify in the climates into the different regimes. Modern climatic classification methods can be broadly divided into the genetic methods, which focuses on the causes of the climate. Then another hand, empiric method, which focus on the effect of the climate. Shortcoming of these classification schemes is that they produce distinct boundary between zones they define rather than the gradual transition of climate property more common in nature. So most common climatic classification are of the Köppen, Thornthwaite, Trivartha. I would like to give the one example here, particularly explain about the Köppen climatic classification, most widely used climatic classification system in the world. The system is based on the concept that native vegetation is the best expression of climate. Thus, climate zone boundary have been selected with vegetation distribution in mind in this classification. It also combines average annual and monthly temperature and precipitation and the seasonality of precipitation. The most commonly used form of Köppen classification has 5 primary types. You can see tropical, B dry, C the mild mid latitudes, D the cold mid latitudes, and E the polar. So he used the alphabet, the English alphabet A, B, C, D and E for denoting different types. Then he also found different type of the subcategory. The Trivartha climatic classification scheme is a modified version of the Köppen system as an answer to some of his deficiency. It attempts to redefine the broad climatic groups in such a way as to be closer to vegetation zoning. Now you can see this here, the different C, and then the subcategory here, the A, B, C, and then D, and then E particularly in the polar area, A in a more tropical situation. So through this, it is very clearly possible to see the different type of the situation in the more upper region. We have the more the snow clad both sides, both region. Then the dry areas, so in middle, the more rain forest type of situation, then the dry deciduous, the both sides, then the the dry region, again the polar region, and the same type of the climatic situation one can see here. I would like to explain a little bit the Thornthwaite climatic classification. This climatic classification methods monitor the soil water budget, using particularly the evapotranspiration as an indicator. It monitors the portion of the total precipitation used to nourish vegetation over a certain area. It uses indices such as humidity index and aridity index. to determine the area moisture regime based upon its average temperature, average rainfall and average vegetation. Such aridity index can also indicate about the type of the desert, type of the arid and semi-arid region we get in different part of the world, including India, particularly in the western side, where you can see the precipitation is less than potential evapotranspiration, and particularly in the western Rajasthan, one can see a clear-cut picture about the large extent of aridity. It uses indices such as this humidity and aridity index, but the lower the value of the index in any given area, the drier the area is. The thermal classification within the third scheme includes also the microthermal, mesothermal and megathermal regime. Now you can see this here through this diagram. I would like to put the climatic regions of India. You can see the highland zone, particularly in the Himalaya, in the upper part, then followed by the humid region. Then western side we have the arid, but between the western arid region and the humid we have the clear-cut semi-arid belt. Dear viewers, here I would like to also elaborate that we studied taking the western Rajasthan as a case in point, and we found that shifting this pattern, like we found that the humid region is shifting towards particularly the sub-humid region, I would like to say, shifting towards the semi-arid, and semi-arid region also converted into the arid region, and so desertification is expanding towards the eastern side and northern side. Then you can find the tropical, wet and dry, and then tropical, wet, particularly in the Western Ghat. It is very important for us, in the era of the climate zone, it is very important for us to understand the interaction among the different climatic system. The main important energy we get from solar radiation, that is, we get the more cyclic type of the pattern, almost the constant, but we get the lot of the climatic variability and the change. On the other hand, several type of the land use and cover change element influences the climate system. If you ask me to identify a very critical factor, that I would like to say the land use and land cover change, like rapid urbanization is taking place, the growth of mega cities, transport development, and so that is why we have the more concrete and the cemented path, and also reducing the runoff in the region. Due to deforestation, we have the significant change in the runoff situation also. Dear viewer, here I would like to mention that we are living in a era of uncertainty. Here I would like to bring before you the climatic uncertainty. After analyzing, we analyze also the data of some of the part of the Himalaya, and we found that in precipitation not a big difference, but if you see the flooding, we get a lot of increasing tendency of the flooding. What it shows? It shows that maybe the macro level, the precipitation is not much influencing the runoff pattern, but the runoff pattern is more influenced by the vegetation or the catchment level. So one can see here the uncertainty from macro to micro level. Macro level, is a rainfall, that is not a very big difference. But when we come to the catchment level, the watershed level, human activities are becoming a more and more dominant, and human activity, channels of human activity I can identify in the form of agriculture, horticulture development, tourism development, several type of also the industrial, the urban, towns and the cities. So this also influences the hydrological cycle also. Atmosphere and ocean interaction. One can see a very also the close exchange between this atmosphere and ocean. The exchange of heat and moisture has profound effect on the atmospheric processes near and over the ocean. Ocean currents play a significant role in transferring the heat, the poleward. Major currents such as the northward, flowing, like a Gulf stream transport, a tremendous amount of heat poleward and contribute to the development of many types of the weather phenomena. The ocean covers nearly 3/4 of the Earth's surface and play an important role in exchanging and transporting actually the heat and moisture in the atmosphere. Most of the water vapor in the atmosphere comes from the ocean, and most of the precipitation falling over land finds its way back to ocean. So this type of the atmosphere and ocean presence, and one can not only atmosphere ocean interaction, but here I would like to say also that land, lithosphere, atmosphere, lithosphere and ocean interaction, and also one can explain as a form of hydrological cycle. I would like to tell you this also the weather phenomena like a sea-land bridge, that is another very important during the daytime and the night time. Sea bridge is a wind from the sea that develops over land near the coast. It is formed by increasing temperature differences between the land and water. These create a pressure minimum over the land due to its relative warmth and forces higher pressure cooler air from the sea to the move towards the inland. You can see here that how during the daytime, during the warming situation what is happening, and then during the cool, night time, the cooling situation. So this processes exchange of the temperature and energy and the wind between the land and the sea. Another important phenomena one can see here, the valley and mountain bridge, and you can see this, how the warm air going up during the daytime and then the cool air coming down. So it is a mountain bridge and the valley bridge. These two are related. Localized winds that occur one after another, particularly in the daily circle. They are not the same as katabatic winds which usually occur in the large scale. During the day the sun heats up valley air rapidly. This causes it to rise and causing a warm upslope wind. On the other hand, night time we get the reverse situation. The process is reverse. Mountain air cools rapidly at night and falls downslope, causing a wind going in the other direction. And so that is why we saw here land ocean interaction, atmosphere ocean interaction, and the important product one can see different types of the extreme weather events. All weather events that cause climatic extremes cause loss of life, disrupt normal human activity and result in the property damage, appear extremes. And so it is very important for us also to see extreme rainfall situation. And maintaining the record of extreme rainfall can give a lot of lesson for the scientists to work and to predict a different type of the rainfall situation in future. Several variables like land use practices, I would like to tell you here also that land use practices like deforestation, afforestation, not only deforestation but the afforestation also. Sometimes we are bringing not a native species and some other type of species, that is also important. High population density, land occupants, one can see a very close relationship between the high density of population and then also influencing the hydrological phenomena, because more population density means the more intensive land use activity, and more intensive land use activity influencing the whole hydrological cycle, and then we get the different type of the complex situation in our the climate system and also on the earth surface. The variability of extreme weather event is so great that even the scientists need a long record of observation and data to establish definite link between the severe events and the climatic changes. It is very difficult to establish so far, but several trends, I would like to tell you that several anomaly we are getting, like in case of Delhi, I can tell you that winter rainfall, particularly western disturbances induce, rainfall. Earlier we were getting the only 2, 3, now we are getting 6, 7. So, and then also the total expansion of the western disturbances. Earlier until the February and March, now this all western disturbances into rainfall we get until the May. So this type of uncertainty situation we get, this requires the long-term climatic data and inquiry in order to come on a particular conclusion. Extreme weather events are rare, which means that oftentimes there are very limited data available to use for particularly for the comparison pattern. Several examples you can see through this diagram, and even in Indian situation also, the flooding, drought, cloud burst, you might have just seen in case of Uttarakhand, in Phalin, in case of the cyclone pattern. Another important phenomena here I would like to mention about the tropical cyclone as a weather scheme. That is a very, very important, and India is very severely affected by this process time to time, and more recently the dynamics of tropical cyclones showing the influence of the Coriolis effect. Note that the storm turns the wrong way, that is the counterclockwise in the northern hemisphere, but for the right regions. Now you can see here the tracks of the distribution and the tracks of the tropical cyclones. One can see the direct influence of the westerly. Also you can see this so that is why the eastern coast of India and also the eastern the coast of the other continent largely affected by this process. The breeding grounds of tropical cyclones are shown in this map. The storm follow curving path. First they move westward with the trade winds, that play which play a very important role. Then they either die over land or turn eastward until they lose power over the cooler ocean of mid latitudes. Cyclones are not spawned over the South Atlantic or the Southeast Pacific because their waters are too chilly, nor in the still air, the doldrums within a few degrees of the equator. Now you can see this the one phenomena, particularly Cuba and Florida area. Extratropicals, that is a more reverse. where genesis and the early development of cyclone largely in the northern different stages. You can see that the how start with the warm air and the cool air, warm in the south and northern cool. Then the how this moving due to the various pressure, and the in next class the we'll discuss the pressure and the different type of the fronts and winds, and then you will be able to understand this phenomena is a more better way. And then in the third stage you can see this the how precipitation develops in an extratropical cyclone. These relationship between the two contrasting air masses are responsible for nearly all high rainfall within these belts and the decreased salinity of the surface water below. After looking this the whole the climatic variable, weather variable, then the processes, it is very important to see the several type of the evidences of the global climate change. You see the sea level rise almost 17 centimeter in last century through this IPCC, global temperature rise 10 warmest year in the last 12 years, warming ocean since 1969 rising, shrinking of ice sheet, particularly the Antarctica, even our in Himalayan region, not all over the Himalaya, but more central part of the Himalaya is also, the melting snow is a more, and Gangotri area also, decreasing the snow mass we are getting. You can see this the CO2 increase triggering the global environmental change, how this graph based on the comparison of atmospheric samples, and you can see in recent phenomena how this atmospheric CO2 has increased since the industrial revolution. A very rapid increase in recent current CO2 level, particularly after the 1900, or more specifically I would like to say the very steep slope in after the 1950. This phenomena is a part of the greenhouse effect, another important driver of climate change. The temperature at the surface, it is very important to understand this phenomena. At the surface of the earth is maintained by the energy balance between the sun ray that strike the planet and heat that is radiated back into the space. Some of the heat is absorbed and retained by the earth or objects on the surface. Much of this does not pass through the air envelope to outer space, but is absorbed by the carbon dioxide and water vapor in the atmosphere and adds to the heat that is already present. This is called the greenhouse effect, which is also responsible for the increase of the temperature over the Earth's surface. The greenhouse effect means progressive warming of the Earth's surface due to blanketing effect of the man-made carbon dioxide in the atmosphere. Now you can see here the temperature change in the atmosphere over. Earlier you can see this, the whole planet, climate has changed many times over the Earth's long geological history. Over the past million years, Earth has experienced several glacial periods interspersed with interglacial warmer periods. Here you can see the time to time. But in recent years you can find the more intensive, the warming. The relatively constant and favorable interglacial period of climatic experience over the past 8,000 years has made human civilization, advancement the possible. It is very important to see this the major factor, responsible for this type of the phenomena. And I would like to, see this the diagram. These two diagram, the diagram below looking the sun energy output. In sun energy output, you can see that the amount of solar energy received at the top of our atmosphere has followed its natural, 11-year cycle of a small ups and downs, but not much net increase. Over the same period, the global temperature has risen very, steeply, And so what you are getting, this indicates that it is extremely unlikely that solar influence has been a significant driver of global temperature change over several decades, and largely this phenomena one can relate with the CO2 and the other human activity and anthropogenic activity. So anthropogenic activity influences the whole global climate change. Now you can see this the possible changes in the surface temperature in the future, present day, but you can see this how by 1990 and then this the scenarios for the 2090, you can see that the how, if you compare the both diagram, the intensification of the warming is taking place particularly in the mid zone, both sides of the equator. So very clear cut visible through this diagram, Now, dear viewer, few minutes I would like to take and give you some idea about the climate of India, a case in point. The climate of India ranges from, the tropical in the south, temperate and alpine in the northern region, and so that is why you can see the altitudinal vegetation zonation model also, that physiographic factors influencing the whole India climate include the Himalaya, the Thar desert, the two very important, the physical landscape. Mean range of temperature varies between 10 degrees centigrade 32, mean annual rainfall 1182.8 millimeter, mean monthly rainfall is highest in July 286 millimeter, and contributing to almost 24% of the annual rainfall. So you can see this the monsoon largely region dominate. Here in this 4 diagram you can see this normal rainfall pattern in centimeter. The upper left diagram showing the winter situation, winter situation where the rainfall is not very, we have the rainfall in the eastern side but not in the large part of the western India. Other side, pre-monsoon time, you can see that again is a more dry time, but monsoon time we get largely the rainfall. You can very intensive rainfall, but one can see the dry region in the western Rajasthan and also in the Kashmir, some dry region. And the post-monsoon time, you can see we get the southern part of India, I think we get, and the coastal, some rainfall, eastern side, but the large part, we get the more dry situation. You can see the same annual normal rainfall pattern taking into consideration of 1949 and 1999, and if you see also the two clear-cut dry region, exist, in the Kashmir, in the particularly Ladakh area, and also the western Rajasthan, and some part of the semi-arid, starting from the Karnataka to, the Gujarat, some part of the Gujarat. Now you can see the temperature. Again, this diagram shows the seasonal temperature at different, like July, you can see the more, not very warm, but at least the some, but we have the more, January, the more cold, and the temperature situation. But in October, if you see in the low temperature in the central high temperature in the central part, and April we have the more warming situation, and so that is why April, May, June we have the more the warming, but again it varies in different part. Northern side we have the more, but in southern side one can get the coastal we have a different type of the temperature situation. So if you see this now 1901 to 2009 data analysis, it suggests that annual mean temperature, for the country as a whole has risen by 0.5 degrees centigrade as per the IM, less than 1 centigrade, 0.56 degrees centigrade as per the IMD. Monsoon rainfall for the same period did not show any significant trend. Dry decades are 61 to 70, 71 to 80, and 81 to 90. Wet decade more 91 to 2000. Winter rainfall is decreasing in most part. So winter rainfall is a very, very important aspect. In pre-monsoon period, rainfall is decreasing for most of the central part of the India. This shows also the broader climatic change pattern, but what through this diagram one can see the climatic uncertainty, not a very clear-cut picture we get, but largely one can see that the blue part is a more cooling showing, and the red part is a red shaded area showing the warming pattern. Dear viewers, it is very important for us to also to understand that the different type of the forecasting the weather phenomena. Meteorologists focuses primarily on the real-time data to predict local or regional atmospheric condition, hours, day and week basis, and so that is why on that basis we can get the atmospheric condition, average and trends pattern that have occurred over many decades, century and millennium. Several tools and techniques. Here you can see this, the balloons, satellite, especially designated aeroplanes, radar and other ground based data. These are the important for collecting the measurement, the wind speed, precipitation, air temperature, humidity level. Sophisticated earth observing satellites equipped with the remote sensing equipment circle the globe to record also the sea surface temperature. As we discussed, sea surface temperature also play a very important role. You can see this, the global climatic, and with improving our technology, we are able to predict the global climatic model in a more finer scale, in a more regional scale also it is possible now. Earlier it was also possible only to global scale, but now we are coming to the local and very regional level. Also, I would like to mention this very quickly here, the climatic and atmospheric research, the global level WMO is very important, IPCC Intergovernmental Panel on Climate Change, the National Aeronautic Space Administration NASA, several satellites, NOAA also giving the lot of the idea. Regional level, the Asia Pacific Economic Cooperation, this APEC Climate Center. If you come to the national level, we have several climate related organizations. I would like to take IITM, and then the India Meteorological Department, ISRO, Ministry of Environment and Forest, Earth Sciences, Science and Technology, Ministry of Agriculture, Ministry of Water Resource Development. These are also monitoring these aspects, and now we are able to get some idea about the climatic situation of India, but it requires the more long range the climatic data analysis in order to come or some conclusion and resolving several type of the climatic uncertainty emerged in recent years. Thank you.
Okay. So what we observe that the forecasting, they sometimes they don't predict the exact. We say about the rainfall or weather or other conditions. So where there is the mistake? What is the missing there?
This phenomena, I do agree with you that we have been not doing much earlier, but now. India got the Doppler radar, and if you see in the last 1 year, we get lot of good forecast, but it's still not a long range forecast. Like I would like to compare with, some Western country, even Japan or Canada or USA, I would like to, 15 days, 1 month before, they see from the internet that when they are going as a tourist or going for a seminar or conference, on that basis, they can take the clothes,
Okay.
on the basis of the forecast, climatic forecast, and almost the 95 to 98, 99%, we have to improve climatic. For that, I would like to suggest that, apart from the governmental organization, it is very important for us that network of because India has a lot of diversity.
Right.
It is very difficult, not very easy to predict the climate and weather for a 1-2 places and then extrapolating for the whole country. We need the different station, more stations we need, equipped with the Doppler radar. Like I would like to tell you, in case of Delhi, for if you want for us, only for if we want to analyze any climatic or precipitation meteorological, for 2 places only we can get data. These 2 airports, Safdarganj Airport and the Palam Airport.
Okay.
Only 2 airports. On that basis, it's very difficult to have the idea of the whole Delhi.
So how many, suppose we want to forecast the correctly the Delhi weather forecast, so how many stations we need?
Now, for Delhi, not a big problem. I think even the one place it is possible, but at least, reach. We have the 2 clear cut, the Jamuna passing through.
Okay.
Jamuna passing through this. We have in the western, this is a very transition zone. Transition zone. So for that zone, we have the desert, influence of the desert in the west, and the influence of the mountain, mountain, and then the water bodies.
Okay.
So for that region we have little bit complex situation. But what I am telling, at whole India level, we have to go to the more decentralized, the network of the climatic monitoring center. But for Delhi, it is possible, to have. We have to use our more, I would like to tell you this, the more space-borne climatic monitoring is also very important. Okay. And particularly not the surface-based monitoring, this station where the temperature measure upper atmospheric phenomena.
So upper atmosphere plays a more important role than the
very important role, okay. But we have the very little, a few centers are there, data. Sometimes it's not available for the academic people also. It requires a lot of cooperation, collaboration and all. So data accessibility is very important. That academic community more. It is very important for that the government department. IMD should cooperate with the university.
Okay.
Even I would like to suggest that they should, help in starting the climatologist and meteorology department in the university system.
Okay, so a kind of collaboration need to be chalked out between the government and the university systems so that we can better forecast.
Yes.
So well friends, with this word we conclude the lecture. I thank all of you for watching the lecture, and on behalf I thank Dr. R.V. Singh for giving such a wonderful lecture and enlightening us with what is the weather, what are the elements, and what we mean by the climate, and how they interlink with each other, and how do they play in the forecasting of weather conditions. So I thank him again. Thank you very much.